Hello, this is Dr. Mears. Today we are going to be reviewing our world applications to TRI. And this goes along with our geometric sequence and series slide deck. A yeast culture is grown in a sugar solution. The concentration of sugar in the solution at the start of the culture is 1.2 milligrams per milliliter and halves every 2 days. What is the concentration of the sugar solution after 12 days? I feel like these should actually be science applications, applying math into science, but I guess yeast culture can be grown around the world, so let's look into this problem a little bit more. First, I always like to set up my position. U sub 1, U sub 2, U sub 3, U sub 4, so on and so forth. So I'm going to take the approach of making a table here, and then I'll take the approach of using our formula. So what I'm going to do is, because we know it halves every 2 days, my next little row is going to be after day. So after day 0, then after the second day, then after the 4th day, then after the 6th day, after the 8th day, after the 10th day, and after the 12th day. Because I know it's every 2 days, that's why I counted by 2s. Let's add another row and put down what the sugar solution will be. In this milligrams per milliliters, this little -1 just means it's going to be written like this. The -1 means the milliliters is going to be the denominator. So it's going to be milligrams per milliliters. There you go. Just repositioning the page for you. So here's your sugar solution. And after day 0, that means our start day, it's 1.2. We know it halves, so I'm going to multiply it by 1/2, or you can do 0.5, and I get 0.6. Again, times 1/2 or times 0.5, and we get 0.3, times 1/2, so on and so forth till that 12th day. So this is after day 12, our sugar solution is 0.1875. Now you can use this table for anyone. Let's look at how we would use the formula. So our formula for a geometric sequence is U sub n equals U sub 1 times r raised to the n minus 1. This is the term number. This is going to be the first term, the term number with that term that you're talking about for that term number. The first term, the common ratio, and the term number is there. Let's substitute everything in. So what we're looking for, and going back to our, show all the work, going back up here to U sub 7, so U sub 7 is that after 12th day. So I'm actually going to want to find U sub 7. And that's how our position and our after days, that this table will help us so that we know which number to put in. So we're going to put U sub 7, it's going to equal 1.2, our start amount, times 1/2 raised to the 7 minus 1. You can put that directly into the calculator, and you're going to get the same answer that we got from the table. There's number 1. Let's look at number 2. Number 2. A student studies the amount of algae in a pond over time. She estimates the area of the algae in the pond on day 1 of her study is 15 centimeters squares. She predicts that the area will double every 8 days. According to her projection, what area will the algae cover at the start of the 9th week? The 9th week. So what I'm going to do is I'm going to take the approach of, actually we can just keep it like this, using our formula. So the first thing that you have to ask yourself is how many days will it be doubled? Because this is saying 9 weeks. And I don't like working in, hey, it doubles in days. What's the 9th week? So let's just change everything into days. So how many days is 9 weeks? Well, this takes some unit conversion. So we have 9 weeks and we want to turn it into days. We know there's 7 days in 1 week. That crosses out the denominator with the numerator. There's your unit conversion. So we're going to have 63 days is in 9 weeks. I feel much better about the problem now. So how many times will it be doubling in week 9? Well, let's see. How many times? So we know that it doubles every 8 days. And we have 63 days to go through. So let's divide 63 by 8, and we get 7.875 times it will double in 9 weeks. So that's a lot of times that it's going to double, about 7.8. However, we want the start of the 63, we want the start of the 63 days. So what we're going to be doing is actually having to round this down because we want the start of the 9th week. Now let's use our formula, U sub n equals U sub 1, r to the n minus 1. We just found our n. So our n was 7. So I'm going to substitute 7 in, do this in the calculator, and we're going to find that the 7th term, or the 7th time it doubles, we're going to come out with 1,920 centimeters squared. So at the start of the 9th week, or the start of the 63 days, the algae will cover about 1,920 centimeters. This has been World Applications. Thank you.